these wonderful students who came along to, some of them came along to the Bionics South East Queensland night, and the student group, and which are two separate nights. And I'd like to get them to introduce themselves because I'm really impressed that they actually put together their own team. And this amazing invention has got such huge potential. So Lex, here on the left, would you like to
go
first?
Yeah, so I came along to the Human Bionics Student Association event that was held the other week here, which was awesome. And so I got to meet Dimity and I told her about this project that we're doing at UQ University of Queensland as part of the UQ Robotics Club. My name is Lex and I'm studying business at the moment, but I'm an aspiring engineer. But yeah, we've got part of the team here. There's a couple of girls and boys who couldn't make it today. They're away on holidays because we've got that mid-year break at the moment. So yeah, these are the guys who could come along, and so I'll get you guys to introduce yourselves.
Yeah, I'm Jonathan. I'm studying mechatronic engineering and IT. I've got a year left to go.
Hey guys, I'm Darren. I'm in fourth year of my electrical engineering degree at UQ, so we're all from UQ. And I'm the president, I guess, of the Robotics Club. And
Yes.
You guess. He is the president of the Robotics Club. And what happened was last year the Robotics Club basically died and there was no one there. It was going to close and Darren put his hand up and decided to rescue it. And thanks to him, this was able to come about. So,
and you know, Lex came along and just said, I want to do this. And you know, if you've got someone with a drive, I think students see that and they want to work on cool projects like this outside of uni. So something.
I'm Tom. I'm doing mechatronic engineering.
how many years ago?
I have 1 year left, hopefully.
Could I ask you some questions as a team before we get started?
Well, the whole team's not here. There's about
How
there's
many
two
more are
other
there?
girls and about 4 other guys as well, so it's quite a big team.
That's great.
Yeah.
How often do you get together?
Once a week, Thursday nights. That's usually the best time. During the break, we've made it a little bit earlier because people don't have any reason to come into university during the day. So yeah, we have a bit earlier because that's more suitable time. So that's on Thursdays, 3 till 5.
Great.
Often later.
Often it keeps going past 5 o'clock, yes.
And whose concept was this? Was that yours, Darren?
No, you can explain it if you want.
All right, so at the very beginning of the semester, we wanted a couple of projects that UQ Robotics Club could do in order to be more than just a get together and have pizza and drinks and what uni students usually do. So this was kind of a project I found online. It was the InMove project. It's an open source humanoid robot that was built by a guy in France, and he's uploaded it. It's online, and so he's released it as open source so that anyone can print the parts. So that's 3D printed, and then that also the instructions on how to assemble it. But the problem was that it's a humanoid robot arm, so it's part of a larger robot from the waist up. It wasn't actually designed for an amputee. So that was the challenge. And bringing all of these students together, we had to come up with how do we get a robot arm that's made for a robot, and then connect that up to an amputee, like what are the sort of inputs, how will we get it to interface with a human being? And so it's been 6 months and we've been able to come up with a solution, but we have based it off of different parts, bringing them all together. This is using EMG sensors, but we can go into detail on that.
Can you explain EMG sensors?
Yeah, so with EMGs, as you'll see John demonstrate with his big muscles, the sensors, there's 3 sensors with EMG. EMG is electromyography. Electromyography? Yeah. So basically, there's one for grounding, and then on the elbow. So, and then there's the other 2 need to go on the muscle belly. So it can go on any muscle. And basically, what it's picking up is the electric pulse that goes through your muscle. And so, I mean, yeah, that's probably quite a crude explanation, but so this is Yassine. You want to give a quick intro to that video?
Hey guys, yeah, sorry I'm late. I'm a mechanical and aerospace engineer with the prosthetic arm group.
Yeah.
I guess I'm kind of leading the mechanical part of the mechanical side of this.
Definitely, good timing.
Thank you.
So with the EMGs, yeah, it picks up as you flex, as Jono flexes, it's picking up the electric pulse that goes through the muscle, in the muscle belly, and then it triggers it within the software. So the software is threshold, so you can measure was it digital or analog? So
Yeah, it's an analog signal. So
analog
like
signal.
when it passes a certain threshold,
Exactly.
like when the strength of the signal in the muscle passes a point, it just clenches the fist.
Yeah. So when it comes back down again, then it unclenches. So that's very basic, very rudimentary. But you can also the next couple of stages that you could do is have it so that you can trigger multiple functions. So say if you wanted to trigger and go over the threshold 3 times in a row maybe, then you could have the arm form some other sort of function. So it might be just 2 fingers together, or it might be these things or these things. So at the moment it is just grasping and then ungrasping.
So things we want to do. So this is just the beginning of the project really. I mean, so someone had come up with the arm and it was just putting a bit of some software, printing the arm out and just putting it together. Now, the next thing would be, he's got an arm, what happens with an amputee? So what happens when this is gone,
Don't do that.
Yeah. Because there are problems there with muscle strength. So maybe because they haven't had enough muscles around there, atrophy quite, so the signal will be less. There's aspects.
Yeah. We haven't actually attached the arm, so what happens there. So there's a lot more challenges and interesting things coming up with the project.
Would it be would it actually be surgically put into it, you're thinking, or would it be harnessed on?
We want it to be for us to be able to do. So we're not we wouldn't be allowed to do any surgery.
And I think a lot of people will be comfortable with less invasive, which is one of the reasons we're looking at surface EMGs as well, because you can have intramuscular EMG signals, which you can get a finer signal from that. But because they're surface ones, they can use the arm and they can just take it off and not worry about it.
Yes.
Yeah, so I mean, we've been able to come this far and develop this, but the point is, it is a prototype, and it is based off of other people's kind of just bringing all different parts together. And so what we'd like to do over the next 6 months is kind of build it from the ground up, and then have a think about whether we want to use tendons. Tom's looking at using DC motors within the hands, and so rather than having these long strings, because problems with that, they get tangled, or it's just also the servo motors, which are these things here, they're quite heavy. And so we want to be able to make it a lot lighter. Just from research, we found that amputees would prefer a larger prosthetic versus one that's super functional. But that, again, we haven't really partnered with anyone who has access. We need to talk to amputees ourselves. That's the next step. This is awesome, we've been able to do it this far, but we're looking at, I'm not sure if Dignity has any connections that we'd be able to connect with, but basically our clients, actual amputees, we need to be able to sit down with them in an agreement, a partnership, and work with them about how do we develop something that's actually useful. Because we get really carried away with how cool this tech is. We could add lasers to it and shoot lasers everywhere, but is that actually needed? And is it going to be light enough? How are we going to make it light enough? Things like that. So, it's been interesting because there's had to be not just robotics students, but a whole bunch of students from different faculties getting involved. So we've had to reach out to human movement, and they've been able to talk us through how the EMG sensors work, and they've kind of shown us there's another alternative which we aren't going to use, but that's implantable EMG sensors, and that. Yeah, so we've kind of gone through and learned a whole bunch of stuff outside of robotics, which is very important because again you're bringing the biology and then matching that with technology. You have to cover know both sides of how it all comes together. So the next stage, this is a prototype. We'd love to, as you can see, it's not portable. The next stage will be out of how do we compact it, how do we make it smaller and lighter, and how do we make it portable. So how would you attach, what sort of batteries would you have, how would you power it? And so we're looking at LiPo batteries, so they're rechargeable, they're small, they're more condensed, and then that's pretty much where we're at right now.
Can I ask some more questions, please?
Yeah, definitely.
One of the things that I'm interested in is the first night of the student bionics group. They had Matthew Ames, who was a speaker. I'm not sure if any of you were there that night.
No,
I don't think were you there? I don't think any of our. Yes, he's got 4 legs that are fully amputated, and he was
Were you
talking.
at that one? Okay.
No, you might have heard of him anyway.
Yeah,
He's offered his services to help talk to people.
Yeah.
He uses a wheelchair on, which is really like a chair, and he can chin operate a lot of things. But he tells me that one of the things that he finds a lot of difficulty with his prosthetic arms is that he can get them up like this, but he can't move out like that. Because if he does that, his wheelchair topples over. It's so precariously balanced. So obviously that's a very bad situation for a man like that who can't get himself up off the floor. So I'd like to hear the ranges of movement of this. Obviously you've got the fingers moving out like this.
Yep.
What else do you think the capabilities of this are attached to an amputee?
Yeah, so again, it depends on how far down the arm the amputee is being amputated. So this we've designed so that we've got at least the biceps and the tricep muscles to be able to work with. And so that's what you would attach your EMGs to. If, for example, this gentleman was to use this arm, I'm a bit curious as to how a wheelchair would topple over if you reached out. Is the arm that heavy?
It's not your normal wheelchair.
Okay.
It's very narrow based, more like a chair with wheels on it.
Yeah.
It's stand almost, isn't it, Emily? It's like
Yes,
it doesn't
it
have
is,
arms,
it
and he
is.
doesn't have any.
That's
So
right.
it can raise up and down, and it's quite manoeuvrable for him. Didn't
But then
quite
the center
ask-
of balance as soon as it
Centre
goes
of
too
balance
far.
is yes.
Okay.
Yes, yeah. So I just thought I'd mention that because that was one of the problems that he mentioned to me that was
Yeah.
quite.
That sounds like an engineering problem for these guys.
Yeah,
I'm interested in solving.
Also, we only have one source of input at the moment, which is like a single muscle on the surface, and it's hard to get more than that with EMG because you can only go on the surface. There's lots of like subsurface muscles that we don't really have access to. It's like theoretically we could build an arm that's capable of actuating like all those motions, but would we be able to control it? Like, would anyone be able to control it?
One of
One
the,
idea is if he can connect with EMG sensors on his body, maybe the arm can be attached to the actual wheelchair, and so it could work like that somehow. And then you could, we've heard of different technologies of having a plate inside your mouth and then controlling by pressure sensors and how to move those arms. You could do it that way as well. So if the problem is that the arm's too heavy and it's tipping over, then we'd have to make the arm lighter, or we'd add training wheels onto the actual chair to stop it from. Sorry.
Or a counterweight on the other side.
Or a counterweight.
How far you move it, just pop out on the weight on the other side.
Yeah, that's another set of
all great ideas.
Yeah.
So I'll see if I can put you in touch with this gentleman. And the other thing I wanted to say is that at the moment I'm speaking to a doctor from Johns Hopkins at the University Hospital in Baltimore, and one of their surgeons is working on a robotic arm that that the patient is able to control by thinking about it. So they've done some work on the nerve endings up here in the shoulder.
Yeah, yeah.
So I might give you that information and that contact before you leave as well.
That'd be great. That's awesome. We've looked at other ways of controlling the arm. So, for example, EEGs, which is through the I forget what the whole terminology is for it, but it's through your brain waves. But that's very limited at the moment, unless you're going to do implants, and then again, that's like a costly process. It's time process. So with EEG at the moment, currently, you have to focus, and then it measures whether you're focused or not. So it's basically an on-off thing. So if you're very much, and the challenge with what we're finding is that you could have an EEG and be controlling the arm, but you have to be thinking a lot about your arm and focused on that. You can't do anything until you've done that, and then you can do something, but then you have to come back to it and then do it and do it again. And then it's also very limited in terms of how many other functions you can do with it. Whereas with EEG, you can match it up with the triceps. EMG, you can do the tricep muscles, and then you can kind of extend and have a whole bunch of others. So yeah, we've also looked at with the reimplantation. Yeah, the reinnovation of the muscles. So that's a very popular process at the moment with amputees, where they transplant the nerves from the arms being amputated into the pec. So then rather than just having, say like the bicep, you've got the 1, 2, with if they're implanted, then you could have 3 different triggers. And so the challenge of having your arm, depending on how high you're being amputated, if you're up at the shoulder, you're very limited in the number of muscles that you can use because you've lost all of these, so you can't take the input from those. And it comes back to just measuring your pec, so that's one muscle cluster. And then you've got your traps, and then on your back as well. So there's a lot of challenges with depending on how far up they've been amputated. And so again, we're kind of focused on around the elbow region and lower.
But I think it could possibly just turn into pattern spotting. So just put it on someone, see what you get, and then if you can spot a pattern and then go, was that you trying to do this motion? Just connect the two. So yeah.
So is John highly trained, or is he just the bloke who sat down in the chair?
Would you like to have a go?
Would you like to? I think that's what he's trying to say.
I'd like to have a
Where's that camera? Would anyone else out there like to ask some questions too? Abby? There's a question here.
What advantages does it have over the Ed 209 program?
Which program?
Ed 209.
So I'm not aware of that program.
Can you explain it?
What are your guys' plans moving forward? So a lot of you guys are, I think, in your final year uni. So what are you going to continue to be involved with the robotics club so you can keep working on this? What are your plans to continue through?
I'm here till the middle of next year. I think a couple of us are here for 1 or 2 more years. I guess the hope is this is just the start, so we can do a lot more. Depends on funding.
Yeah, it's just, it doesn't matter.
Students are. Yeah, it doesn't matter. Try it.
Doesn't matter.
What are the numbers looking like?
Yeah, way good.
Alright. Now tense your arm. See what happens.
Do you want to try switching around?
Yeah,
See, maybe
No?
This is a worry.
No muscles.
You're not getting a signal at all.
Do you want to try like?
So we can actually see some numbers that are coming off there, so kind of like the voltages that we can read here. And really what you can do is you can just have a play with the numbers. If you notice that when he's doing this, you get this number, and you do this, you get a different number, you just say, hey look, what was the something in the middle? So it's quite easy to change, and this is just really basic stuff. And then just having a play with that environment. Yeah. So what sort of numbers are you getting?
Give it another go.
So there, Tom just changed the numbers.
Yeah,
So
everyone is
different people at a different threshold for muscle strength. So yours will be too high the whole time. Your muscle was just musclier than mine.
I've always liked you, Jono.
and theoretically we could make it like adapt to that in real time without programming again. So.
Well, so Amanda was just making the comment that so we have mapping for our cochlear implants. So what you've just done is a bionic arm map.
Well, it's probably not anywhere near as complex as that. It's just like one muscle. Yeah.
I see a great similarity.
Yeah.
And I see that
No, you have to do that because, as I said, it gets to a certain point and it just clenches right up.
Did you much like of the mechatronic, sort of like the robotics at the Bionics or here in say?
No. I mean, you know, Dimity's obviously this is, you know, for us an extension of what is the bionic ear, right?
Yeah.
And
I guess so.
but really the reason, the clever thing that Dimity did 20 years ago was see the linkage between the technology and the therapy.